Tonight, if you step outside and find the constellation Orion, look at his shoulder. There is a bright orange star there. Its name is Betelgeuse. And that star is going to explode. That is not a maybe, it is a certainty. It could happen in 100,000 years, or it could happen tonight. When it does, it will become the brightest star anyone alive has ever seen. Bright enough to see in broad daylight, bright enough to cast shadows at night. And here is the part that will keep you up. Betelgeuse is 640 light-years away. Which means the light we see tonight left it 640 years ago. So it may have already exploded, the blast may already be racing toward us. And we would have absolutely no way of knowing until the light finally arrives. Welcome, you're watching To the Moon and Back. Here we travel to the real places and the real events hiding in the dark. Today, one dying star, one explosion, and the night it changes the sky forever. So let's ask the question, what if Betelgeuse exploded tonight? To understand the explosion, you first have to understand the star. Betelgeuse is not a star like our sun, it is a red supergiant, a monster. Our sun is already over 1,000,000 kilometers wide. Betelgeuse dwarfs it completely. It is roughly 700 times wider than the sun. The numbers stop making sense. If you placed Betelgeuse where our sun is, it would swallow the inner planets whole. Mercury gone, Venus gone, Earth gone, Mars gone, all inside the star. Its surface would reach out past the asteroid belt, almost to Jupiter. It is one of the largest stars we can see with the naked eye, and it is dying. Its surface is not smooth. It boils and churns in enormous, restless cells. Each bubble of rising gas is wider than the entire orbit of the Earth. The star is so bloated that its own gravity can barely hold it together. It sheds huge clouds of gas and dust into space, losing mass all the time. It is bright red for a reason. Red means cool, and its surface is relatively cool. But do not be fooled, inside it is a furnace winding toward catastrophe. Betelgeuse sits about 640 light-years from Earth. Far enough that it is a single point of light, but what a point of light. It is one of the brightest stars in our whole night sky, even from that distance. For thousands of years, humans have watched it burn at the shoulder of Orion. Every culture that watched the sky knew this red star. But here is what makes it extraordinary. Betelgeuse is incredibly young. Our sun is 4.5 billion years old and only middle-aged. Betelgeuse is barely 10 million years old, and it is already dying. How can a star die so young? Because it lives so hard. The bigger a star, the faster it burns through its fuel, and the sooner it dies. Betelgeuse is 15 to 20 times the mass of the sun. And that mass is a countdown, a fuse burning toward its final second. To see how that fuse burns, we have to look deep inside the star. Into the furnace at its heart. A star is a constant battle between two titanic forces. Gravity pulling everything inward, trying to crush the star into a point. And the outward push of nuclear fusion, burning in the core, holding it up. For most of a star's life, these two forces are in perfect balance. Deep in the core, hydrogen fuses into helium, releasing enormous energy. That energy is the light and heat we see. It is what holds the star up. But fuel runs out, and Betelgeuse has already burned through its hydrogen. So it moved on to burning helium. Then, when that ran low, heavier elements. Carbon, neon, oxygen, each one harder to burn than the last. The star becomes like an onion, with shell after shell of burning elements. Each new fuel buys less and less time, the countdown accelerates. Burning hydrogen lasted millions of years, helium far less. By the final stages, each fuel lasts only years, then months, then days. Finally, the core begins to fuse silicon into iron, and iron is the end. Iron is a dead end. Fusing it does not release energy, it absorbs it. The moment the core fills with iron, the star's engine has nothing left to burn. The outward push vanishes, and gravity, which never rested, finally wins. The silicon burning that fills the core with iron lasts only about a day. A single day at the end of 10 million years, the last day of the star. And we cannot see it coming. The core is buried under the whole giant star. From the outside, Betelgeuse looks the same the day before it dies. The catastrophe is sealed deep inside, invisible until the very last instant. Which is exactly why we cannot say when, tonight, or in 100,000 years. On the scale of the universe, that is the same as saying, any moment now. And once the iron core reaches its limit, everything happens terrifyingly fast. Not over years, not over days, the final collapse takes less than a second. In that 1 second, the star tears itself apart. But before we witness it, there is a strange chapter we have to tell. Because a few years ago, Betelgeuse gave us a genuine scare. For a while, we thought the explosion might have already begun. Late in 2019, astronomers noticed something unsettling. Betelgeuse was fading, its light dropping week after week. It grew dimmer than it had been in the entire history of careful measurement. By early 2020, it had lost more than half of its brightness. The star's famous red shoulder in Orion was visibly, eerily faint. And people began to wonder, was this it? Was Betelgeuse about to explode? The internet lit up. A supernova in our lifetime seemed possible any night. Telescopes around the world turned to watch the fading giant. Then slowly the star began to brighten again. The scare was over. So what had happened? Astronomers pieced the answer together. Betelgeuse had not been dying, it had in a sense sneezed. It belched out a huge cloud of gas from its surface into space. That gas cooled and condensed into dust, forming a dark veil. And that veil of dust simply blocked much of the star's light from reaching us. It was not death, it was the star shrugging off part of its own outer layers. A normal, if dramatic, part of life for a restless, dying supergiant. But the great dimming taught us something important. This star is unstable, restless, visibly changing on human timescales. It is behaving exactly like a star in the final chapter of its life. So while the dimming was a false alarm, the warning behind it is real. Betelgeuse is close to the end, and one day the real event will come. So let's stop waiting, let's watch it happen. Deep in the core, the iron reaches its limit, and the star runs out of time. With nothing left to hold it up, the core collapses under its own gravity. In less than a second, a core larger than Earth crushes down into a ball. A ball just a few kilometers across, denser than an atomic nucleus. The collapse happens so fast the outer star has no time to react, it is left hanging. Then the collapsing core hits a limit and violently rebounds. A shockwave erupts outward, tearing back through the falling star. And in that instant, the core releases an almost unimaginable flood of energy. Tiny ghostly particles called neutrinos pour out, carrying titanic energy. That flood slams into the outer layers and blasts the whole star apart. This is a supernova, the most violent explosion in the modern universe. In a matter of days, it releases more energy than the sun will in its entire life. A single dying star, briefly outshining 100 billion others in its galaxy. The explosion forges new elements in its fire: gold, silver, uranium. And it flings them out across space at a fraction of the speed of light. The expanding shell of gas glows with the heat of the blast. For weeks it grows brighter, then slowly over months it begins to fade. All of this for Betelgeuse may have already happened 6 centuries ago. The blast of light may be crossing the final light years toward us right now. And when it arrives, there will be no warning, just a sudden new star. One ordinary evening, Orion rising as it has for all of human history. And then at the shoulder, a point of light beginning to swell. Growing, brightening hour by hour into something no living human has ever seen. So step outside with me on that night and look up. Because from 640 light-years away, this is what we would see. Not danger, not destruction, a show unlike anything in recorded history. The sky is about to change, and it will stay changed for more than a year. Here is what the night of the explosion would look like from Earth. At first, nothing seems wrong. Betelgeuse simply looks a little brighter. Within hours, it is the brightest star in the sky and still climbing. Over a few days, it swells into something impossible to ignore. It becomes as bright as a half-moon, squeezed into a single blazing point. A single star casting your shadow across the ground at night. You could read a book by its light, you could walk a dark road without a torch. The whole world would gather outside, night after night, to look up. And then it does something no star in living memory has done. It becomes visible in broad daylight, a star shining in the blue afternoon sky. A pale, fierce point of light hanging beside the sun, refusing to disappear. For weeks, Betelgeuse would blaze there in the day and in the night. The single brightest supernova in all of recorded human history. Every culture, every city, every person on Earth watching the same new star. Imagine the awe, imagine the fear before we understood what it was. For our ancestors, a new star like this was an omen, a message from the gods. For us, it would be something better, a front row seat to a star's death. Telescopes would drink in every second. It would be the most studied event in history. We would learn more about how stars die in a month than in a century before. And then gently, the show would begin to fade. Week by week, the blazing star would slowly dim. First, it would vanish from the daytime sky. Then, over months, it would fade from the brightest star to an ordinary one. And finally, after more than a year, it would fade from view entirely, leaving behind a gap, a missing star at the shoulder of Orion. For the first time in all of human history, the shape of Orion would change. Every star map, every constellation drawing, suddenly out of date. Children born after that night would never know Orion the way we do. To them, the hunter would simply always have had one shoulder. A small, permanent change to the night sky, a scar we would all share. But while all of this unfolds in our sky, a fair question grows louder. A star just exploded and threw out more energy than the sun ever will. So the obvious question is, are we in danger? A supernova is the most violent explosion in the universe. It sounds terrifying. It floods space with radiation, high-energy particles, and blast waves. If one went off close enough to Earth, it could be a genuine catastrophe. Close enough, it could strip our ozone layer and bathe the surface in radiation. It could trigger a mass extinction. Some in Earth's past may have done exactly that. So how close is too close? Astronomers put the danger zone at about 50 light-years. Within 50 light-years, a supernova could seriously harm life on Earth. So the crucial question is simple: how far away is Betelgeuse? 640 light-years, more than 10 times beyond the danger zone. Far, far too distant to hurt us, not the ozone, not the climate, not a single cell. When Betelgeuse explodes, it will be one of the safest spectacles imaginable. All of the danger spent harmlessly across 6 centuries of empty space. By the time its light reaches us, it is pure beauty and no threat at all. There is one more worry people raise, a focused beam called a gamma-ray burst. Some dying stars fire these deadly beams from their poles. But Betelgeuse is not the right kind of star, and its poles do not point at us. So even that far-fetched danger simply does not apply here. The verdict is clear: Betelgeuse exploding would harm no one on Earth. It would be a gift, a once-in-a-civilization light show, watched in perfect safety. The last time humans saw a supernova this bright was 1,000 years ago. In the year 1054, a star exploded and blazed in the daytime sky for weeks. People across the world recorded it, and it left something behind. Something we can still see today through a telescope, which brings us to the aftermath. Because when the light of Betelgeuse finally fades, the story is not over. A supernova does not simply end, it leaves ruins, beautiful glowing ruins. The blasted-out layers of the star keep expanding into space for thousands of years. They form a vast glowing cloud, a supernova remnant. Delicate filaments of gas glowing in every color lit from within. That thousand-year-old explosion left us one of the most beautiful of them all. A tangled, glowing web of gas still racing outward 1,000 years later. Betelgeuse would leave a remnant just like it, right there in Orion. A glowing cloud where a bright star used to be, visible for generations. But at the very center of that cloud, something small and strange would remain. The crushed core of the star, the part that collapsed in that final second. A neutron star, a city-sized ball containing more mass than the sun. So dense that a single teaspoon of it would weigh billions of tons. Spinning many times a second, sweeping beams of energy across space. The tiny, dead heart of a once mighty giant. If Betelgeuse is massive enough, the core might not stop at a neutron star. It might collapse further still into a black hole. A pinpoint of pure gravity, where the shoulder of Orion used to shine. Either way, the giant we see tonight would be gone, transformed forever. From a bright red star to a blazing supernova, to a glowing tomb and a dense core. The whole life and death of a giant played out in our own sky. And here is the strangest, most beautiful part of all. That explosion so far away would not just be an ending, it would be a beginning. Because the elements it scatters are the same ones that build new worlds. And that is where this story comes home to you. Look at your own hand, the atoms in it did not come from nowhere. The iron in your blood, the calcium in your bones, the oxygen you breathe. None of it could have formed in an ordinary star like the sun. These elements were forged in the hearts of massive stars and in supernova. Every heavy atom in your body was born in a dying star long ago. Explosions like the one Betelgeuse is about to have, scattered across billions of years. Those explosions seeded the clouds that became new stars, new planets, and us. You are quite literally made of the ash of dead stars. So when Betelgeuse finally explodes, it is not just destroying a star. It is doing the exact thing that once made you possible. Scattering the seeds of future worlds and maybe future life into the dark. Somewhere in that expanding cloud, in a billion years, new planets may form. Built in part from the atoms of a star we once watched at the shoulder of Orion. The death of Betelgeuse is a link in a chain that has no end. Stars die, they scatter their ashes, and from those ashes new things are born. We are one link in that chain, and Betelgeuse is about to add another. So tonight when you find Orion, look at that bright red shoulder. And know that you may be looking at a star that has already died. If that gave you chills, then you belong here. This channel is a map of the strangest real places and events in the cosmos. Subscribe, and every week we travel somewhere no human will ever stand. Tell me in the comments, do you hope Betelgeuse explodes in your lifetime? There is so much more out there, and so much more to find. Thanks for watching To the Moon and Back. Keep looking up.